3, sum and difference inequalities. Not inequalities, identities.
I was wondering about that.
I was like, wait a minute, that is not the right word.
I was wondering if I had the right section.
Oops. See if I can get in the right page here. All right, so 2, the tangent of 15 degrees. So I need 2 known angles that when added or subtracted give me 15 degrees. And I would typically try to stick to stuff in quadrant 1 if you can, instead of going to these other quadrants and end up with positives and negatives and all that fun stuff. But there are a ton of angles that can subtract or add to give you 15 degrees. Not add, but subtract. So which ones do you want to use?
45 and 30.
45 and 30. So 45 minus 30. So we have the formula is tangent of 45, same sign on top, minus tangent of 30, over 1, opposite sign on the bottom, plus tangent of 45, tangent of 30. What is the tangent of 45? One minus tangent of 30.
I'm gonna go root 3 over 3.
Yes.
Root 3 over 3 over. Might be a good time to reiterate you won't get a unit circle on your exam.
Oh, so it's a good thing I remember these.
So
Definitely should know these things.
I would
Getting
make sure,
practice.
well, I would at least make sure, because remember, if you learn it on one hand, it follows the pattern. So if you at least memorize quadrant 1, you would be able to get through the rest of it. But if you get to a problem where you really need it, you can always draw it out. Like, it's not like that. I mean, it would take you a few minutes, so it might not be worth your time to just do that from the start. But if you get to something where you need it, you know.
It's not like the stats exam where you're supposed to spend 20 minutes on one problem.
Yeah, well, no, this is like that too.
Oh.
There'll be one math problem that it will tell you to spend like 25 minutes on, and then the other ones will be like you have 5 problems to spend like 60 minutes on.
Dang.
You get the whole time, but that's how long they tell you that you should spend on it. All right, so I've got 1 minus root 3 over 3 on top, and on the bottom I've got 1 plus root 3 over 3 because times 1 anyways. So what do I need to do to finish solving this? Conjugate of the top or the bottom?
Bottom.
Yep, conjugate, so times 1 minus root 3 over 3. So we would get on the top 1 minus 2 root 3 over 3 plus 3 over 9. It's a perfect square trinomial, just a weird one. I feel like something's wrong, but I don't know. Anyways, and then on the bottom we would have 1 minus 3 over 9. So I'm going to rewrite these ones as 9 over 9 just so that I can visually see this. So on top, I'm going to have 12 over 9 minus, I'm going to go ahead and get a common denominator here as well, okay, in the middle. So I'm going to make this a 9 on the bottom, meaning I need to multiply this by 3. So 6 root 3 over 9 is going to be to get the common denominator, just so that I can avoid having to write this out extra times. Are we tracking what I did there? Okay.
Makes sense to me.
All right, so on top, I have 9 plus 3, so 12 over 9. Or, well, yeah. And then minus 6 root 3 over 9. So 12 minus 6 root 3 over 9. All over 6 over 9. Now what? Keep, change, flip. So I'm going to get 12 minus 6 root 3 over 9 times 9 over 6. 9's cancel. Now what happens?
You can take out a 6.
I can take out a 6 from the top so that then I can cancel stuff. So this would be 6 times 2 minus root 3 over 6. 6's cancel. And finally, we are left with 2 minus root 3. And I don't know if you remember, but all of your tangent problems when you're done should come out to look like this in some form or fashion. And then the sine and cosine ones will all look similar in their final answers. Like if you're getting some crazy numbers or something other than like 2, root 3, root 6, and 4, those are like the numbers for these problems. If you get something other than that, something is wrong. I guess hypothetically a 1 could be in there as well. But anything other than that, I would be concerned that something is wrong and look at it again.
I mean, I guess 1s are everywhere, really.
Well, yeah, but I mean like 1 plus something, like in that fashion. Let's see. Let's do a cosine one. 4. Cosine 75 degrees. So what two angles when added or subtracted can give me 75?
45 and 30.
45 and 30. So not sine. Wow. Cosine. Of 45 plus 30. So that formula is cosine 45, cosine 30, opposite sign for cosine, and then sine of 45, sine of 30. What is the cosine of 45?
Root 2 over 2.
Root 2 over 2. Cosine of 30?
Root 3 over 2.
Root 3 over 2. Minus sine of 45.
Root 2 over 2.
Root 2 over 2. Sine of 30.
1/2.
1/2. And then I'm going to get, I have a common denominator on the bottom because it's going to be 4. It's 2 times 2 on both sides. So I'm going to go ahead and write this all as one thing. Root 2 times root 3 is?
Root 6.
Root 6. Minus root 2. And that would be your answer for that one. So again, that's what the sine and cosine answer should look like in some form or fashion, positive, negative, something along those lines. For these ones, for sum and difference, I think sine and cosine are easier, but for double and half angle, I think tangent, or at least half angle tangent tends to be easier mathematically. They all end up being a lot of steps, but with half angles, but. Okay, let's do a sine one, and it's going to be one in radians. So the sine of 7 pi over 12. So I would convert this first because I'm assuming off the top of your head you're not figuring out what two fractions add up to give you 7 pi over 12, right? So I would want to convert 7 pi over 12 to degrees, so 180 over pi. Josh, did you already get that?
Not yet. Hold on. 105, maybe.
So 180 divided by 12 is 15. So times 7, so that might be right.
I just wanted to see if my head calculator was working properly.
I think so.
Oh, it is.
All right. Huh?
I'm gonna say 85, but I don't know where I got that from.
That was a little late, Riley.
A little bit.
All right. Somebody other than Josh, what two angles add up to give me 105? or subtract.
60 and 45.
60 and 45. I like it. We're keeping it to quadrant 1 angles. So the sine of 60 plus 45. So at this point, if for some reason they just asked you to like show how it would be written or something like that, you could also at this point say, well, this is the sine of pi over 3 plus pi over 4, right? And that would be another way that you could do it to go back and show that it was 7 pi over 12. Or if they had you then writing it out as the next step that we're going to do, you could write it in terms of radians instead of degrees. But we're just going to keep it in degrees at this point just to make it easier. So sine 60 cosine 45, same sign for sine. So plus sine 45 cosine 60, which I think I said that backwards of what it should have been, but it doesn't matter.
The properties of the math say it doesn't matter.
Yeah, exactly.
The math doesn't care.
Anyways, as long as you have both pieces, it doesn't really matter. All right, so at this point, this is where I'm saying you could, if they were to give it to you, it would be the sine of pi over 3 cosine of pi over 4 plus, you know what I mean. So, all right, what's cosine of 60? Sine of 60. I'm all over the place today. Root 3 over 2. Cosine 45. 2 over 2. Plus sine 45. 2 over 2. Cosine 60. And again, root 6 plus root 2 over 4. Nice and easy.
Love it when they're easy.
Me too.
Does it matter that the formula is backwards? Or like the
No.
sine cosine switch?
No, I wasn't thinking about it and I just wrote it backwards. I just knew that they had to be opposites, so I just wrote them and then I was like, wait a minute, that's backwards.
Fair enough.
So what's the property called?
Commutative. Is that the
Yeah.
one?
I'm so bad at those. I still don't know.
I always start out algebra 2 with that and people always freak out about it. I'm like, this is the one and only time of the year. There's going to be one problem on the quiz and one on the test where you have to use them. That is it. Like,
What was that one? Like the properties?
the properties like commutative, associative, identity,
Ew.
those things.
We
I
know how they
remember writing
work.
that in my
It's just we
notebook.
forget what they're called.
Yeah. Well, that's the thing. The whole point is to get you to know, like, what works and, like, what you can do.
It's same with like proofs. Like I know what I'm doing, I just don't know what it's called.
Yeah. That was my problem in college. Paragraph proofs. I'm like, look,
Paragraph?
yes,
We didn't have to
paragraphs.
use- No, we just did the chart proof.
No, these are like completely different. Like, there's no numbers in them. Like, that kind of proof. So, but I'm like, I know why, like, I know that I can do this, but I don't know why. Like, what in the world is a silo theorem supposed to be to tell me how to answer this? Like, that was what I had to do a project on. I was like, how in the world is that supposed to help me with anything? Like, I just know that it works. I trust the people who invented this, that they did it right.
Yeah.
Like, I can prove the Pythagorean theorem. I can prove the quadratic formula. Like, I can prove that the square root of 2, like, I can prove what it is. I can prove to you that 0.9999999 is equal to 1. Like, I can prove things like that to you because I don't have to give you explanation as to why. I just show you how to get there.
Yeah.
But they want to know why. And I'm like, I don't. Like, I'm sorry, but I don't. Like, I'm not going to teach this in college. At the most, I would teach Calc 1 in college. And I probably wouldn't even teach that. Like,
Yeah.
I would say, like, pre-cal and under. But I have to get a master's in math, and I ain't doing that. Too much work. So, Mr. Law was like, don't you want to get your master's so that you can teach, like, dual enrollment math? And I was like,
Nope.
not in math. I was like, if you can find a college that'll let me teach dual enrollment with a master's in underwater basket weaving, sure. Like, but they're not going to. Like, my best friend has a master's in administration.
Yeah.
But she couldn't teach math in college. She could teach administration in college, but she couldn't teach. So I'm like, what's the point?
Yeah.
Like, anyways, that's why we had to go to AP so many years ago, because Mr. Cass has a degree in electrical engineering or nuclear engineering or something.
Wow.
So he was originally teaching at ODU and at Thomas Nelson, and they said, "Oh, your master's isn't in math," even though he has way more math than most math majors because engineering just takes that much math. They were like, "But so you can't teach it anymore." So I was like, if you can find somewhere that will let me, I'd be happy to get a master's in something, but it's not going to be math.
Yeah.
I was like, I won't pass. Like, that's how hard it is. He was like, oh, I understand. I was like, I would love to. I'd rather it be dual enrollment for the kids' sake, but I can't do that. So
Yep.
find another option. Like, AP it is. Okay, are we good on the ones of setting the formulas up?
Yeah.
Okay.
Yes.
So then this year, something that's different is we're going to do the reverse.
Oh, yay. Love that.
And when I say reverse, don't be alarmed. It's not starting down here. It's starting right here.
Okay.
I was
like,
like, starting right there.
I'm never gonna figure that out. Never.
So we'll do a couple of these as well, and then we'll be done unless y'all have questions. So cosine 94, cosine 18, I guess I should say degrees, plus sine 94, sine 18. And I want you to write the expression as sine, cosine, or tangent of an angle. Now notice these aren't known angles, so we wouldn't actually be able to do this by hand. We would have to use a calculator for if we were to continue the process downward, but we're doing reverse. So which single function would this be?
Like the cosine of 76 degrees.
How'd you get there? Show me the
So-
intermediate step.
Okay, so this would be a cosine of like A minus B.
Okay, so 94 minus 18, which then would be what you said, the cosine of 76 degrees. So are we tracking on the working backwards thing now? Not as bad as it sounds, right?
No.
So this is another thing that could be like a multiple choice type question. They could have you working backwards, or just trying to get to that point particularly,
Yeah.
depending. So 14 sine of pi over 3 cosine of pi over 7 minus sine of pi over 7 cosine of pi over 3. Now for these ones, I'm going to tell you, you need to leave these in radians. Just because these are easier, right? Because we know that which function does this go with?
Sine.
And are we adding or subtracting? Okay, so we know this is going to be the sine of pi over 3 minus pi over 7. Okay, so now I just need to get a common denominator in there and combine them. So what would my common denominator be for this?
21.
So this is going to be the sine of 7 pi over 21 minus 3 pi over 21, which would be the sine of 4 pi over 21. So you kind of see why we don't really want to work the other direction. You would not have come up with pi over 3 and pi over 7 by looking at 4 pi over 21 without really intently thinking about it, most likely. So that's why I say with these ones, you do need to leave it, just because on the exam, they would expect you to leave it in the same thing that it started in. But let's see, is there a tangent one? Okay, there's one. Let's do one tangent one like this, and then if y'all are good, we'll be good. Tangent of pi over 5 minus tangent of pi over 3 over 1 plus tangent of pi over 5 tangent of pi over 3. So which situation do I have here? Or how would I write it?
The tangent of pi over 5 minus pi over 3.
Yep, tangent of pi over 5 minus pi over 3. What would my common denominator be on this one?
15.
15. So this is going to be the tangent of 3 pi over 15 minus 5 pi over 15. Tangent of negative 2 pi over 15. Interesting. We typically, if we were working it, like, let's say we started with this and we were going to work the other way, I would typically tell you to get a coterminal angle to do that. Not that you can't do it with a negative, but it's a lot easier to deal with the coterminal angle. All right, are we okay on all this? All right. I'm basically going to give you one of each function from each of the sections. If you feel like you need to do more, that's fine. 1, 7, 9, and then 11, 15, and 17. I was like, there's got to be another cosine one in there. So anyway, so you have one of each trig function of each kind.